In the 1998 science fiction classic Deep Impact, the film comes to a dramatic crisis point as a large asteroid slams into the Atlantic Ocean. Given that the Earth's ocean covers 71% of its surface, a deep impact event such as the one portrayed in this film is more likely than any other impact scenario. This is of grave concern because recent population studies tell us that the overwhelming bulk of humanity lives along or near a coastline. And what you're going to see in this program is that this concern is now greater than ever before. And worse yet, the threat has begun to skyrocket in the last few years. Deep within each of us is a racial memory of rocks falling out of the sky and killing people. And sometimes it's a little difficult for us to handle. So like children, we turn on all the lights, lock the closet door, jump into bed and pull the covers over our heads and say, if the monsters can't see me, they can't hurt me. Well, you know, there is a little bit of truth to that because asteroids and superbolides cannot see us. But that will not stop them from killing us. On February 15, 2013, a superbolide meteor blindsided everyone on the planet, including NASA and the Russian Air Defense System. Entering Earth's atmosphere at a shallow angle, it growled through the skies at 60 times the speed of sound and detonated over a remote region of the Chelyabinsk Oblast at an altitude of 18.4 miles above the ground. Thankfully, nobody died, but nearly 1,500 people were injured, including 311 children. There were a few serious injuries, but most were hurt by glass falling on them, or worse, having shards of glass blown into their faces by the detonation as they looked out their windows to see what was growling across the sky. When the superbolide detonated, it was momentarily 30 times brighter than the sun, which caused hundreds to suffer eye pain and temporary flash blindness. This is because when the Chelyabinsk superbolide detonated, it released 30 times as much energy as the little boy uranium bomb dropped on Hiroshima on August 6, 1945. One can only imagine the death and havoc an event such as this would have created had it detonated over a major city like Paris, New York, Moscow, or London. And so as the story faded from the front page, as all stories do, it was out of sight and out of mind for most. But for a few in the science community, the event triggered a new awareness that perhaps we'd become complacent about the threat of an impact event. Nonetheless, when it does come, and it will do so with a vengeance, what will you do then? Where will you drive to when the streets become parking lots? And where do you hide from a mountain of water? Nowhere. This is why in the first program in this series, Planet X 101, Who, What, When, Where, Why, and How, we presented our initial analysis of fireball observation reports. Our source is the American Meteor Society, and you can learn more about this reporting site at amsmeteors.org. For over a year we've been studying their reporting data, and what it told us is that for those living along a coastline, it's time to bust a move inland. In my case, it was from Santa Cruz on the northern California coast to Reno, Nevada. But that's just me. As for you, if you live along a coastline and you're watching this, then I also suggest you visit our site at yowza.com, that's YOWUSA.com, to read my article, It's Time to Bust a Move. Then you decide for yourself. In this program, we're going to give you a detailed analysis of AMS Meteor Observation Report data. Let's get started with yearly trends. At Yowza.com, what we're tracking are fireball reports, those big ugly rocks that fly through the sky and make the evening news. And this year started with an interesting twist, so to speak. So let's get caught up. The AMS reporting data presented in our first program in this series, Planet X 101, Who, What, When, Where, Why, and How, was through to October 2013. In this program, we'll update that to include the first quarter of 2014. So let's get started. Here we see the complete actuals for all of 2013. Based on those 2013 actuals, here are the monthly estimates for 2014. Now let's see how the 2014 estimates compare with the first quarter of 2014. In January, the estimate is spot on. The actual for January is consistent with the estimate based on the prior year actual. However, in February, we see a drop, not only from the estimate, but from the February 2013 actual as well. Again in March, we see the same thing as February. The actual is below the estimate as well as the prior year actual. So what could account for this? First off, we're not talking about meteor showers like the Perseids, which many of us enjoy watching on warm August nights. Rather, we're tracking fireballs such as the one observed over Japan in January of this year. Large, solitary rocks that come screaming out of the heavens. With that in mind, here is one explanation for the first quarter drop in fireball observation reports. As we've reported, we're tracking an approaching second sun in our system. Astronomers have named it Nemesis. It is the core of what we refer to as the Planet X system. Nemesis is a brown dwarf companion to Sol, with its own planets and rings as well. To illustrate one explanation for the drop in the 2014 first quarter fireball observations, let's use this illustration of the rings of Saturn as the backdrop for our example. In this case, the data could be telling us that Earth is now between the bands. Therefore, we do not really know what is coming next. Another bigger band? Or could it be over? With either scenario, the terms coincidence and natural variability come to mind. They did for us, and for that reason, we dug hard into the data. And here is what we found. Let's assume that the brown dwarf at the core of the Planet X system is like the other massive objects in our solar system, in that it is also surrounded by rings. So, are we encountering those rings? If so, how would it be expressed in the data? Let's see. For the purpose of this study, we're going to use a line graph instead of a bar chart. And here we are starting with the 2013 to 2014 actuals based on current AMS reporting data. Using this data, we can project through to the end of 2015, and this shows a steady uptick. Then when we extend the projection out to 2016, we see an even greater uptick happening. And finally, when we go to the end of the projection in January 2017, the trend does appear ominous. With this in mind, let's see where the Chelyabinsk superbolide that detonated over Russia on February 15, 2013 fits into this picture. Here we have added the Chelyabinsk superbolide to our previous timeline. What it shows is that there has been a steady uptick in actuals since that event. However, when we expand the timeline to cover the period 2009 through January 2017, this is when we really begin to get a sense of what is happening. This is not coincidence, nor is it natural variability. And if you're living along a coastline, you should be concerned. Now let's take a look at multi-state observations. The interesting thing about the Chelyabinsk super bolide that detonated in the skies over Russia last year was that it came right out of the sun. And so both the Russian air defense system and NASA were completely blindsided. This is why we take a special interest in multi-state fireball reports, as these tend to be large fireballs or super bolides with shallow trajectories such as the Chelyabinsk super bolide. It's not uncommon to see reports coming in from 3 or 4 states for these large fireballs, or in some cases, 2 or more countries. So let's see what the data tells us. Here we see the updated actuals for all of 2013, which tracks closely with the yearly trends we saw before. Using those actuals, we were able to project estimates for 2014. So let's see how the estimates compare with the first quarter of this year. In January, we're seeing that the estimate and the actual are spot on. While the February actual is well below the estimate, it's not that far off from the 2013 actual for February. And in March of this year, we see that the actual is on par with February, but significantly lower than the actual for 2013 as well as the estimate for this year. But if you think we're out of the woods, don't draw that conclusion in haste, not until you see what we have next. The AMS dataset is very rich with many different types of data, but the one that really gets our attention the most are called huge events. In the first program in this series, Planet X 101, Who, What, When, Where, Why, and How, we introduced viewers to the AMS classification system, where mid-sized events get 6 to 20 reports, significant events get 21 to 50, and large events get 51 to 100. Huge events get 100 plus reports. The huge classification is usually reserved for the biggest, brightest, and noisiest space rocks. These are the ones we need to worry about, so let's take a look at the trend data. Here we see the actuals for 2013, and the first thing we can't help but notice is that it's a bit spotty. Then, using the general trend projection, we created 2014 estimates for huge events. So let's see how the estimates fit with the actuals so far for this year. With January of this year, what we now see is a reverse in the earlier trend data for the first quarter, which shows several reporting types with lower values. Then in February, a surprise. Since there were no prior year actuals for this classification, we could not make a prediction. Nonetheless, there were 2 huge events in February. It's also interesting to note that there were no huge events in March. So was February a fluke? We wondered about that ourselves. But as we were finalizing our study, a huge event occurred in April. Like February of this year, there was no estimate because there was no prior year actual. So while we are seeing a downward trend for the first quarter and the earlier categories we showed you, what we're seeing with the huge classification is anomalous and disturbing. To help put this in context, we're now going to present the two most significant trends in this report. We're now going to show you the two most significant trends: huge events and multi-state events. We are going to use 2013 actuals for multi-state events and huge events to set a baseline for this comparison. And here we see the addition of the 2014 estimates, which track closely with the 2013 actuals. With this in mind, we are going to see how the first quarter of 2014 compares with the 2013 actuals and 2014 estimates. Here we see that January 2014 is right on track with the 2013 estimate for multi-state events, but a little higher for huge events. For multi-state events in February 2014, we see a drop below the 2013 actual level. However, huge events are still significantly above 2013 actuals and 2014 estimates. In March, we see the downward trend for multi-state events has leveled out a bit. But on the other hand, it has plummeted in terms of huge events. Once again, we factor in the late reporting data for huge events in April of 2014, and we see an uptick that does rise above the 2013 actuals and the 2014 estimates, while at the same time we're seeing a virtual flat line on multi-state events. In terms of similar reporting outside the U.S., we did not find any sources as competent or as thorough as the American Meteor Society. But this is what we did piece together. There was no significant reporting of fireballs until September 2013. Since then, we've been able to follow two principal areas. In Europe, we're seeing multi-country reports that span all the way across Europe, over the UK, and some even as far as Ireland. In Oceania, we're seeing multi-country reports that span the distance from New Zealand to Australia. These observations are based on the timestamps of the reports. Given that 71% of the surface of our planet is covered by oceans, we believe that unless these trends dramatically reverse themselves this year, there is a high likelihood of a deep impact event in our near future. This was a key factor in my own decision to bust a move from the Santa Cruz area of California to Reno, Nevada. Now, for those of you living along a coastline, I hope you take the information presented in this program to heart, and that you do the same. And just remember, every day of procrastination is one less day of survival options. And I'll leave it on that note. So until the next time we meet, remember Marshall's motto: destiny comes to those who listen and fate finds the rest. So learn what you can learn, do what you can do, and never give up hope. This is Marshall, and I'll catch you on the backside.
I'm Chief Meteorologist Jamie Simpson. Have any of you seen this image on Facebook showing what appears to be two moons in the sky? Maybe you've seen this circulating in an email. This is actually two moons from Saturn, by the way. Maybe you've heard. Will the moon be as big as Mars? Will it look like this? No, it will not. The truth is, it's a hoax. First circulated back in August 2003, and at that time, Mars was the closest to Earth in long time, thousands of years. Then again in 2005, 2007, also hoaxes, and is rumored to happen again at 12:30 a.m. on Tuesday. Well, what will you see? Well, the moon and Mars will be very close to each other in the sky, but Mars will only be about 1/140th the size of the moon, and it's all about the distance from the Earth. This is about how they'll look on that night and pretty much any other night. The average distance of the moon is 238,000 miles from Earth. Mars is a much larger planet. In fact, Mars is bigger than Earth, but at its closest, it's at 34 million miles. So if you do look outside up in the sky at that time, it should look more like this.
VP 113, jokingly dubbed Biden. Get it? Corey Powers, editor-at-large for Discover Magazine in studio. How you doing, Corey?
VP Biden.
Right on.
There we go.
Correct on that. Two images show you. This is the arrow obviously pointing to it. But there are three dots on here. One is red, one is green, one is blue.
Right.
What's significant?
So this is the actual discovery image. Basically, two astronomers were looking one little patch of sky very, very far away, looking for exactly this kind of thing. Stars don't move. Planets or anything that's like a planet does. So this is color-coded. This is what they saw on different nights. They're looking for one thing moving. They color-coded it to show that all these stars are staying still. This thing is moving, and the way it's moving...
So this is just one...
It's one object, color-coded.
Is Pluto on this?
Pluto's in a whole different part of the sky.
So this is way out there.
This is way out there. This is more than twice as far away as Pluto.
Unbelievable. Why does this matter, Corey?
Well, there are two ways you can look at it. I think I look at it first of all as an exploration question. That we know where we are on Earth. We've mapped our planet. Our solar system is still terra incognita. It's full of surprises. This object is something that astronomers said shouldn't even be there. There's a whole other solar system beyond the planets that we know that are full of these things that are sort of planets, sort of comets. Some of them they call dwarf planets. That's what they're calling this one. What we're seeing is we're seeing our neighborhood. We're seeing what's around us. And then the second part is we're seeing where we came from.
Go back to the other image, you guys, and we'll show, because we're over here on the left, right?
That's right. So we're over here.
Okay.
There's
Pluto's out here.
Yeah.
And this thing called Maki is way out here.
That's right. So that's another dwarf planet. If you want to find out where VP 113 or Biden is located, keep walking about another 30 feet that way.
Wow. You can see that far.
And this is the closest it gets this time. When it really gets cooking, it's 15 times as far away as Pluto.
That's incredible.
It takes 4,300 years to go around the sun.
I don't know how you know that, but I trust you. What is a dwarf planet?
So a dwarf planet, the fact that you hear weird terms like that is actually scientists saying there are things out there we don't really understand. It's a dwarf planet is kind of a catch-all term for something. It's round like a planet. It sort of looks like a planet, but it doesn't orbit in a regular way like all the planets that we knew growing up.
Would this be part of our solar system?
So it's part of our solar system.
Would it be outside?
It's a whole new zone. They're calling it the inner Oort cloud. You don't really need to know that. All you need to know is there really are these two solar systems. There's the solar system with the classical planets, and then there's this whole other zone that we haven't explored. And now they're saying because of how this new dwarf planet moves, that there may actually be an even bigger planet, something bigger than the Earth.
I guess that's the point I was going to, because you study this all the time. Is that why it's so significant? Because there's more beyond that?
There's more beyond that, and then there's more beyond that. I mean, I think what we're seeing is, if you watch the show Cosmos, I've been kind of glued to that. And in the last episode, they were talking about the discovery of comets and the discovery of our place in the solar system. We're still learning that. We're still learning this right now, and there's still.
Man. All right.
Yeah.
Just like you're out of space, I'm out of time.
But this, this is where we came from. This is why we're here. Oceans, continents, air,
Thank you,
us.
Corey.
It's all part of that.
You got it, man. Good to have you back.
Planet may be hiding a pretty huge secret. Well, two huge secrets, actually. Astronomers in Spain believe that hiding behind Pluto, obscured from our view, are two additional giant planets. Spanish scientists in Madrid discovered the potential for the two massive celestial bodies at the outer reaches of our solar system after studying strange patterns in the orbit of rocky objects around Pluto, including the newly discovered dwarf planet 2012 VP 113. Scientists believe the first hidden world would be about 10 times the mass of Earth. They believe that this planet is moving in resonance with a bigger planet that is somewhere between Mars and Jupiter in size and would orbit 200 times the Earth's distance from the Sun. But can we ever conclusively confirm the existence of these two planets? Well, Scott Shepard at the Carnegie Institution for Science had this to say. As there are only a few of these extremely distant objects known, it's hard to say anything definitive about the number or location of any distant planets. However, in the near future, we should have more objects to work with to help us determine the structure of the outer solar system.
Ingenuity, huge amounts of computing power, and then hours and hours, months of discussions with colleagues and poring over the data to validate the results.
Thank you. I realize you're focusing on near-Earth asteroids today, but there's been so much talk about the potential for finding a Planet X or some sort of large body through the WISE survey. Can you comment on any status on that sort of search, or maybe even reassure people that Planet X isn't coming to get them next year?
Yes, this is Amy Mainzer. I'm happy to answer this one. Planet X is not coming to get us. But we are looking to see if there are any other bodies in the outer part of the solar system with the WISE data. This is a very natural project for WISE. And so we're still working on it right now. We've obviously just returned a huge amount of data from the telescope that's going to take us a long time to sort through. But the initial results are very promising. You may have seen earlier results where we've discovered a new class of very cool type of stars with WISE. But the search is still on, and we don't think that there's anything that's hazardous in the outer solar system. We think that this is just a sort of if there is something out there, it would be a large body in a roughly circular orbit.
Our next caller, Denise Chow from Space.com. Denise.
So when you say the initial results are very promising, yeah, the initial results are very promising. Anything else you wanted to say on that point?
We've actually been able to confirm the discovery of 100 new objects that are these very cool stars called brown dwarfs. And so that's very similar to what people are interested in looking for. So we've actually found some of these that are relatively close to the Earth, but none of these are closer at this point than the nearest star to our solar system. So it's a good start, though.
Thank you.
Okay, now we're going.
Seek